Good morning, everyone. Welcome to the Post-Market OS talk. I'm happy to introduce Luca. He's an engineer for Fairphone, working on Android and the kernel. And yeah, he will tell us more about this interesting effort of a digital independence in your pocket. Have fun.
Thank you. So yeah, welcome to my talk. Post-Market OS, digital independence in your pocket. Let's see what this is about. So my name is Luca Weiss. In my day job, I'm software engineer at Fairphone, but in my free time, I'm also Post-Market OS core contributor. So I'm doing a lot of different things there, and I also have some other projects on the side, like OpenRazor. So let's start off with kind of an overview of the smartphone landscape that we are currently in. So essentially, we have a duopoly of operating systems. We have iOS, which is running on iPhones, which are only manufactured by Apple. And then we have Android, which is in general a free operating system, which is being used by a bunch of different manufacturers to make different phones with them. But most of the consumer electronics are actually then shipping with Google Play, because this is more or less required for the average end user. Because everybody wants to get their apps from Google Play, and if they can't get their favorite, I don't know, Instagram or Uber app, then they will not be happy about this. I think Huawei has tried at some point to break into this market and make their own ecosystem, but as far as I know, it also hasn't gone like anywhere, at least in Europe. But by shipping Google Play as a manufacturer, you are then bound by Google's requirements and all of their policies, which means to some extent it is good because they're enforcing some bare minimums that an Android device needs to fulfill. So, for example, needs to ship with an up-to-date security patch level and can't be too old of an Android version. And it also ensures that the Android apps are actually compatible with, or that the Android system is actually conforming to what Android should be, because every Android build is being built from essentially a different source tree. To ensure that actually then this new source tree that is being used is actually conforming to what Android should be. A bunch of tests, or many millions of tests exist to make sure this is correct. But being bound by Google policies also means that there's definitely reduced independence of what you can ship as a manufacturer. And there's also a bunch of strict requirements, so it is becoming, or it is not very trivial, or it's not trivial, unfortunately, to update Android versions for a long time because of different, basically different things that Google is requiring from manufacturers for shipping it. And of course, also working with Google means you're working with a US company, which may or may not become a problem at some point. Right now, it is not a problem, but who knows what the world is going to be? And maybe we don't want to be fully dependent on basically Apple being a US company and Google being a US company, and there not being any alternative essentially. There's basically all Android devices are shipping with Google Play. This applies to phones and tablets and like general consumer electronics. There's also many Android devices which are not shipping Google Play, which are like custom, for example, kiosks or payment terminals or printers or like whatever. So like Android is also being used in a lot of other contexts where Google Play is not that relevant. But still, for like consumer electronics, people want to get their apps, and Google Play is unfortunately the way to get it. So yeah, duopolies, I think we know. I've just described both US companies. They control the whole market essentially. There's very little competition outside of these two in terms of operating systems, and it means, for example, there's not a lot of like privacy-friendly options available. So with Google Photos, for example, this is a pre-installed app. This is the default gallery on a lot of devices. And often when you open this app, like, I don't know, every week or something, if you don't have the photo backup enabled, which syncs all of your photos to Google, you're getting a pop-up. Please enable photo sync. And the checkbox is enabled by default. So if you just want to quickly click through it, all of your photos are getting synced to Google. So if you use this app, essentially either on purpose or an accident, you will sync all of your photos to Google at some point. It is the duopoly is a problem for independence because Android is being developed essentially top-down from Google. Google is dictating what to do, and if you don't like it, then it's your problem. And you can adjust it to some extent, of course, because it's open source, but also still all of the development work is being done there. And in theory, you can contribute to AOSP and get your contributions upstream, but in practice, it is often very difficult to actually get your contributions in because of either a lack of review on Google's part or like who knows what. Even some minor features sometimes take like years to get merged, even though it has gotten Code Review +2 at some point on their Gerrit instance. But yeah, I don't quite know why it works this way, but it is it is my experience. For all of the devices, essentially, there's a lot of proprietary code running on the app. I mean, so in a later slide, I will explain a bit more about the different parts of that are in a phone, essentially. So, I mean, yes, no smartphone can work completely without proprietary code because there's just too much, let's say, technology going on there. But the board support package, so the standard code that you get from an SoC manufacturer, so the chip manufacturer, there's a lot of proprietary code in there, and there's basically no way around that without doing a lot of, a big amount of engineering work. And so, in my role as at Fairphone, we do have some proprietary code from Qualcomm, for example, and we have the source code that, and we could patch it and modify it, and then ship the pre-builds to the end user. But even quite a lot of things that we as a manufacturer get are proprietary or pre-builds. So we cannot even look at them, we cannot debug them. We are basically completely reliant on our suppliers to be able to fix problems with them. In the software updates, as I said, it's a lot of work to upgrade to a new Android version on a device. And you're also then bound by Google to approve every single Android version that you're shipping, and this takes a long while. And yeah, it just also it ties back to the independence point a bit. Yeah, so to explain a bit, so on an Android device, Android is always running on the Linux kernel. The Linux kernel itself is GPL 2.0 licensed, which means that all the modifications to the Linux kernel that are shipping on the device also need to be made open source based on the GPL licensed. I put the asterisk there for all kernel-related parts because there can be drivers in Linux or loaded into Linux which are not, I think, called a derivative or something of Linux because they are re-implementing basically a lot of stuff. So, for example, there's some proprietary file system drivers, and for example, also ZFS on Linux would also basically fall in the same category because it's not GPL compatible. And same thing with the proprietary NVIDIA driver and things like this. But generally, everything in the kernel is open source, at least everything that's mostly relevant to it. But then there's a lot of custom drivers in these kernels that don't conform to, let's say, what generally the Linux kernel is implementing in the interfaces. So there's a lot of non-standardized things going on in the layer between user space, so everything running on top, and the kernel itself. Which brings me to the hardware abstraction layer. So this is a bridge between the kernel, or whatever interface the kernel implements, and then the high-level frameworks, for example, the Java code, or in Linux mobile case, a dbus interface or something. So basically just a bridge of how can applications or the UI basically, for example, vibrate with the vibrator. But in the Android land, there's a lot of tight coupling between the HAL and the kernel interface because it's not standardized. And in theory, a lot of these HALs could be very generic if the kernel interface would actually conform to the regular standards. There's actually a cool project called ASPM, and maybe some Lineageos bits coming at some point, where essentially all of the Android parts are also generic across different devices because the kernel is just implementing standard interfaces. So then even the Android build can be quite similar for a lot of devices, and not every device needs a completely custom Android build. And yeah, this tight coupling in the hardware abstraction layer also means that it's difficult to replace the kernel on an existing system with a newer version that where the interfaces have changed, for example, because of this tight coupling. So, for example, if you want to upgrade your kernel with all of the proprietary bits that a manufacturer gets from Qualcomm, for example, this is getting very difficult because you need to then make sure to keep the kernel interfaces reasonably similar or similar enough to so that the hardware abstraction layer that you are keeping is still working. So Linux and Android is only running on like basically one of the parts on the whole SoC, so the chip in the system. So basically just on the ARM on the big ARM CPUs, and all of the other chips in there, so the GPU, the NPU, the ADSP, the modem, etc. They're all running proprietary firmware, which is signed with the keys of the manufacturer in the most cases. So it is, in that sense, impossible to replace it. There are some devices that don't ship with Secure Boot On, so where the signature verification is not available or not being turned on. And there, in theory, it's possible to replace a bunch of these firmwares. But as far as I know, there was basically zero work done in that regard because it's a very obscure, also it's a different CPU architecture and everything, and you would need to reverse engineer a lot of different things. Yes. So a lot of people ask, like, what is the difference between like other Android operating systems, and so for example Lineage OS or EOS or Calyx OS, compared to Linux Mobile, so Postmarket OS, for example. And yeah, so like for in these Android ROMs, and also for these Android ROMs that don't like to be called Android ROMs, they are more open source than the stock operating systems in most cases, because at least all of the Android parts are open source. So for example, the Android framework or basically the framework / base in Android, this is open source but it's still far from like 100% open source between the kernel and user space and everything in between. Because a lot of these proprietary blobs, so just binaries and libraries from the stock operating systems, just get taken as is and being put into the Lineage OS build, for example, which is necessary to make things work because nobody has spent the effort of actually re-implementing all of this hardware abstraction layer and modem interfaces and everything. Nobody has re-implemented this for open source in Android. Which also means if you're taking all of these binaries from the stock operating system, then you're also relying on the stock operating system to actually update them. So like if there's a problem, if there's a security issue, if there's anything else, you're just bound by the original Android manufacturer to release an update that fixes your problem, mostly by accident because they don't really care much about, for example, Lineage OS. And also the Android parts in AOSP, they are all they're mostly Apache 2.0 licensed, which means you can, like any person can essentially take this source code and then make make a binary from it, and then just keep the source code for themselves. So this is quite different to the GPL licensed. So let's talk about Postmarket OS. So our tagline is essentially the Linux distribution for mobile devices and beyond. And so we basically have a lot of different focuses in that sense, or like a lot of things that make us stand apart from Lineage OS and everything. So we really focus on having a fully open source user space and kernel space, of course. And we are doing this for security, for actually knowing what is in the devices, for being able to change it, being able to modify it. And a big focus on this is also then that we actually can support the devices in the long term, which both means for us that we have less effort per device to maintain it, because a lot of things are just shared between different devices. We don't have big device-specific adaptations for it. And it also means that the devices should be supported for a long time, which means that they don't need to get thrown away because the operating system support is stopped, because it was too much effort for this specific device to do it. Postmarket is also currently a completely independent project. Basically, everything that's being done is completely volunteer-driven. We are getting donations in which we are now paying to work on some specific projects, which I will talk a bit later about. But yeah, basically 99.9% is everything's done by volunteers. And yeah, essentially we are a Linux distribution, a regular Linux distribution with package manager that is running on phones. We are based on Alpine Linux, so we have the APK package manager, and we are providing a bunch of different things on top of Alpine Linux, which kind of makes up Postmarket OS in that sense. So we have some tooling to build images and build packages and make it possible to compile packages for your phone from your x86 laptop, for example. We're providing a bunch of extra packages on top of Alpine Linux, which are obscure enough to not make much sense to put into Alpine Linux directly. So, for example, some device-specific kernels, or some firmware packages which are needed for a device, or some specific Qualcomm modem binaries, or binaries as in daemons, open source daemons. We also have an build infrastructure, which is building our packages, but also building pre-built images for the devices. So you can download some from our website and then directly flash it to the device and have that ready. And you don't, for those, you don't need to use our command line tool to assemble an image yourself. And we also have quite some information in our wiki, wiki.postmarketOS.org. We try to people document a lot of things in there. I wouldn't really compare us to the Arch Linux wiki, but we at least aiming to be something like this for phones, essentially. So how to flash things to a phone, how phones are working internally a bit, what things differ between the different ARM SoC manufacturers, and all of these things. So there are other projects which are Linux and mobile that work a bit differently, that actually do reuse some Android parts in their operating system. This is mainly Ubuntu Touch and Sailfish OS. There's also some others that I'm aware of. And yeah, so the basically the description for the umbrella project for these is, or Sailfish OS actually doesn't use Halium as far as I know, but still same thing. So Halium is a collaborative project to unify the hardware abstraction layer for projects which run GNU/Linux on mobile devices with pre-installed Android. And basically Halium is a project to take the original Android kernel that was running on the device, or so mostly a years-old kernel version that has millions of lines of code changes to the original kernel version that was shipped upstream. And it's also reusing the Android runtime and the hardware abstraction layer to get hardware support working, and this is mostly proprietary. And it then provides some bridge between the Android components and then the regular glibc or Muscle user space. So, for example, this includes libhybris, which then is translating also from the Android libc to the glibc or Muscle. I actually do think that these projects that are using Halium or the Android parts, they're actually quite cool because it is definitely a pragmatic approach. Because you are relying on top of a lot of things that already work. You have a working GPU driver, you have a working camera library with good quality. You have all of the modem bits which were developed by the original manufacturer. So a lot of things are already working in that sense if you provide this bridge to the user space. And it actually does provide quite a good environment on making a usable operating system. So Ubuntu Touch is working really well on a lot of devices. So also camera quality is really good because it can reuse all of these parts and still provide a Linux user space on top of it. So I mean, Ubuntu Touch is not quite Ubuntu because it has a read-only file system, but still it is essentially a Linux desktop on top of then the Android parts. But basically, as I explained before, again, it's basically the same approach as with Linux OS. It is still relying on proprietary software. If it doesn't get updated on the Android side, you can't update it on your custom Linux operating system then. And also the integration into for example, Phosh, into this environment is not quite, it's quite tricky because the interfaces are quite different. And from what I've heard, it's not really very well maintained. Like there's not really a beautiful approach to make these things work together. And in my opinion, it just like relying on this just doesn't encourage the development of actually open source solutions that can be used on phones, which Postmarketers does. Postmarketers goes in the other way. We basically start from nothing and then build up basically these solutions that we need from the ground up. That's why a lot of things are not working yet. But it doesn't mean that once everything is working, we have a completely open source user space there. So in Postmarketers, we are mostly focusing on using the upstream kernel or mainline kernel. This in comparison is to using the downstream kernel, so the original kernel that was shipped with the device, with most of the time like millions of lines of code of difference and being stuck on some old long-term support release of Linux. So staying up to date with kernel developments is quite important. Because first of all, user space actually does like using new features that are coming in the kernel. So it's not just systemd and Docker that are actually using a bunch of features, but also other software can really make use of this. And yeah, I mean, from these pieces of software, the minimum kernel requirements are only going up, because why should you support a kernel from 10 years ago if there's no point to it? Why can't you just use the new things and just update your kernel? But it's also important because kernels that are not getting LTS updates essentially, or any sort of attention in long-term support, are not secure. There's security issues in every software, we know this. And if they're not getting patched, then you are vulnerable. And these LTS kernels, until more or less now, I think most of these LTS kernels were maintained for 6 years at a time. So, for example, the 4.19 kernel was maintained from 2016 until maybe like 2017 until last year or something. But then the kernel is end of life. It's not getting security patches anymore from kernel.org. You cannot take them anymore. So if you really want to stay secure, you need to then essentially backport the security patches on your own, which is a lot of work. And that's the reason why Upstream is not providing this anymore, because it is just getting too much work, and you can't maintain a kernel forever. Sure, some enterprise distros do this, and they have a lot of engineers. They put a lot of money into this, but basically anybody who's not a big company that actually, where there's like a more or less a core focus, just cannot afford this. Also, even merging stable kernel into these Android forks with millions of lines of changes are surprisingly difficult. With most of the LTS updates, you are getting some merge conflicts because new upstream patches are patching things which were modified by, for example, Qualcomm. And then you're getting new merge conflicts. You need to spend quite some time to understand this merge conflict. What is the original, or what is Qualcomm's patch changing? What is the upstream patch changing? And then figure out how to integrate these both together, and then pray for no regressions. Using upstream kernel means that you're future-proof. You can update to new kernel versions because you don't have millions of lines of changes. You have maybe 20 patches on top of mainline, which most of the time are really nice to rebase depending what you have. Of course, the goal of also in Postmarket.os is to get all of the patches upstream for all of the kernels. For various reasons another, some patches just stay in the kernel fork at least for a while until things basically until things move a bit upstream or some things are getting resolved. But still, it's way less work than trying to rebase all of the kernel support that Qualcomm added in a really old LTS version to like any newer version. Yeah, so like of course, if you're updating to new kernel versions, even with upstream, you can get some new regressions in there. But then it's also important to not wait a whole year, for example, for the new LTS, but actually keep on top of it and keep testing. Keep reporting issues, because only by reporting issues things can get fixed, essentially. And also, if things get fixed upstream, your specific device is probably not the only thing that is being affected by a particular bug. So getting this fixed upstream means actually all of the devices are getting the fix, which is really nice. Yeah, and using an upstream kernel, as I was going on before earlier with the hardware abstraction layer, it makes things quite a bit easier, because then the interfaces are the same. You don't have to have custom user space for every device, because, for example, the way a vibration motor worked is the same on all of the devices, because there's a standard interface for this. It also means that for distributions that you don't have to have a separate kernel version per device, which a lot of Android versions actually need to have, because every manufacturer or for every device has a separate kernel, because it has some patches to just make this one specific device work correctly, and there's no generic solutions essentially being developed there, or at least they're not being integrated together. Yeah, and with upstream kernel, you can actually build the same kernel binary. So if you build the latest Linux master from today with the default dev config, it probably works on like hundreds of devices. Maybe not with the extra stuff that is not upstream yet, but you have the exact same kernel binary, an ARM64 kernel compiled, and you just give it the correct device tree blob, which is a kind of hardware description, and then it's booting and everything's working as expected, or at least the things that are upstream then. So like in post-MarketOS adjacent projects, let's say, where a bunch of this upstream kernel development for phones is happening, there are basically the development's always done per SoC. So, for example, there's a GitHub organization called ST70 to 80 mainline, which is a shared repository for all of the SM70-25 and QCM6490 and SC70 to 80 devices, which is basically just 3 different numbers for the same SoC. And there, basically, it's a shared kernel for all of the devices, because there's some commonality of patches needed on top of Linux to have this. It could also be merged together, so we could have just one kernel for all of the Qualcomm devices that we have in post-MarketOS and support it that way. But then it's a bit more effort in terms of testing, because things still actually need to be tested before you ship them on phones, unfortunately, because it's still quite in development, so it's not super stable yet. But yeah, for example, there is actually in post-MarketOS, you can select the Trailblazer device, which is just a generic ARM64 device, which pulls in a generic latest kernel, and then you can probably be booted on your device if it's supported upstream. So a bit about how post-MarketOS is right now. So this is more or less anecdotal evidence. We don't really have any hard numbers right now, because we don't track users. And we just hear, like, if people post on Mastodon about something that they've done, or they write us on GitHub or write us an email or something. So we know that some people are definitely using the post-MarketOS as the daily driver, as their main device. I think most of these people also then carry at least some other device still for things that are not working perfectly stable yet, unfortunately. So basically for phone calls. Is one of the big things. Then post-MarketOS, I wouldn't call it quite limited. I don't actually know why I put limited there. We have 129 devices in the community category and 292 devices in the testing category, which is more than 400 devices, which is, I think, actually quite a lot of big number. But it's not every device on the market. So And we also still have 257 devices, as of I think yesterday, in the downstream category, which is reusing this downstream kernel, but with just a fully open source user space, which means even less stuff is working there because, for example, the GPU driver just doesn't work with this downstream kernel. But yeah, the devices in community category, they are actually in general rather usable. So I think all of them you can at least boot to your UI and do some basic things with it and basically navigate around the UI with it. But then there's different levels of functionality, whether Wi-Fi works, Bluetooth works, and these things. But in general, in community category, it's working reasonably well, so you can mess around with the phone quite nicely. All of the testing devices, it is a big pile of from barely anything working, but it's booting the upstream kernel, to nearly everything's working, but it's still in testing in the testing category because nobody has moved it to the community category yet, essentially. I would say Postmarket is not yet ready for the average person, but it's definitely ready for the average hacker. So like just people who like to tinker with devices, essentially, and like to tinker with Linux and mess around with technology. There's also still, like, if you look at the device support for a given device in the Postmarketers wiki, then you see basically a bunch of Ys for yes, it's working, P for partial, it's sometimes or like partially working, essentially, or an N for it's not working. But it's more or less a thing of like, is this functional? Like, does it work? Does the camera work when you open it like directly after booting? It's a bit different to like, does the camera still open after a day of having the phone running and having opened and closed the camera a million times because you want to take some photos. So there's some difference between having a feature functional versus having actually stable. I had a talk at FOSDEM 2025, so this year, where I was talking, I had a whole talk about this and how to get actually Postmarketers, I think was the remaining 20% of Postmarketers or something. But yeah, so stability is definitely lacking in some of the areas that we currently have. So especially audio is one of these cases where we know that, for example, on devices where phone calls are working, so you actually can hear the other person, you can talk to them. We do have some stability problems on a lot of these devices where sometimes the microphone just doesn't work at all, you can't hear the other person, or the sound is really high pitched, or the volume is too low or something, where it just wasn't, like, there's still some problems there. But in general, it is functional some of the times. So what are Postmarketers' plans for the future? So we, as I mentioned before, we are a volunteer-driven project. We don't really have a lot of central management because just everybody does what they really want to do. But yeah, there's definitely a lot of things going on that are being worked on. Also, using a few of these things are also happening with the money that we got for donations. Which is really cool to actually now be able to pay some people to really work on some topics that just no volunteer really wanted to do, essentially, or didn't have the time to spend a lot of time on a specific thing. So we really want to get systemd ready. So we have systemd on Alpine Linux instead of OpenRC, which we were using before. This just enables us to integrate a lot better and have less reliance on a bunch of weird shims that were developed over the years. So like from 2012 or something, we have some projects in there that provide some amount of desktop integration for some bits. So really want to get this ready, get this shipped. We want to get some patches that we have for systemd upstream to compile with the musl libc, and also get some things into musl. We want to get an immutable system working, so where actually where the rootfs is read-only, and you have your data in a separate partition, which also can mean that we are actually getting reliable updates to the devices, and not just APK upgrades. So using a package manager upgrade, which is in general working quite well, especially now with the APK, so with the latest version of the APK package manager, it actually became quite a bit more reliable and not failure to like random network issues. we're working on automated testing setup, so we can actually put hardware, so smartphones or tablets, into a shelf, have them controlled remotely, and for example, be able to test different changes, so either directly post-marketers changes, or also, for example, boot the latest kernel version upstream on a device, see automatically if there's any regressions, for example, if the device doesn't boot at all, or if there's some other different things there. So we really look forward to having this. We already have the software or the control part figured out for the most part. We're still missing the hardware PCB to actually control it nicely. But it should be getting there hopefully reasonably soon. As I was saying on the previous slide, we really want to tackle some stability issues and reliability. Trying to figure out different ways there of also getting, for example, the driver for switching the call audio so basically getting the modem to send the call audio to the speaker. Getting this into a better state is really something we want to do. We're also currently looking for a new name, which kind of is more reflecting what our goal is, so not just kind of reviving e-waste after like you don't want it anymore, which was definitely how we started out as. So in the beginning it was a bit of take any old random phone from your drawer and put Linux on it and then have something on there. But now we actually want to we really think it's or really want to get a really usable phone operating system for people, and not just be the basically you get a Telnet on or you get SSH on your random old phone that was in your drawer. We're also working on trying to get the installation a bit easier and getting the documentation a bit a bit better. And also, working on some infrastructure topics, governance, and doing a bunch of work there. So, what can you do with post-marketers today? So, as I said, 400 devices. You probably, if you have a couple of devices from like the last 10 years or something, there's probably at least one of them in there where post-marketers will run on. And yeah, install it. Boot it, hack around on it, install different stuff on there. It's like, as I also said earlier, in the different categories, so the testing, community, and main categories, these ports are the most useful and the most, as the post-marketers project, let's say, we like these ports the most because they're running the upstream kernel, which means you can install any software essentially on it and you won't really have any big issues because it's a really, really old kernel version. In the downstream category, we do have, for example, devices which are still running kernel version 3.0 or 3.4 or something, which are from like 2012 or something, and you can't run Docker on there because Docker actually requires new features. You can run it headless, so without using the screen, so just putting it, plugging it in somewhere, installing a web server on it, or installing yesterday at the stand we were installing a Matrix server on one of the phones, because why not? It's Linux, you can do it. You can cluster multiple phones together into a Kubernetes cluster or like host a web server. There's a solar-powered web server running on compose.party, which is just on an old phone with a solar panel attached to it. You can convert it into like a media playback control tablet, your old tablet or your new tablet. So you can do so many different things with it. You can use it with the GUI. You can actually try to use it as a let's say a home phone of like watching YouTube videos and stuff with it. So you can do really a lot of things with it. There's so many cool things going on that are using post-marketOS. And I would really encourage you to try something on your own. Like if you have any crazy idea, nothing's too crazy for doing this. But yeah, post-marketOS will not get better without contributions. We are volunteer-driven. I mean, everybody's a volunteer essentially. And so doing upstream work, so improving the ecosystem is actually really important for us because we are mostly shipping kernels, which are then at some point hopefully up in kernel.org, but it's also more or less independent. We are shipping the UIs from, for example, GNOME or Phosh or Plasma. So really, to improve PostmarketOS, you need to improve. You can work on upstream projects, which are then also improving, for example, what Mobian is using. So between kernel development, so actually doing some hardware enablement and fixing some of the stability issues that we have, to the middleware, so the feedback-D or libcamera projects to make cameras better, or have your RGB LED or your vibration motor work a bit better, to improving the UI, making new apps, improving existing apps, and basically also a lot of these apps, especially in the GNOME ecosystem, they're also the main apps that are being used on the desktop. So it's just basically when you just minimize the window, you get a nicer mobile interface for it, which is thanks to libadwaita. And you can also just help maintain some packages, especially in Alpine A parts, because most of the packages that we use are in there. In the PostmarketOS PMA repository, we only have a couple of extra ones, because also a lot of the PostmarketOS team contributions actually go into Alpine Linux to maintain the packages there. So, for example, more or less all of the GNOME stack, the KDE stack, and a lot of other packages are maintained by people who are active in PostmarketOS. But there's also a million ways to help as a non-coder coding person. So just try it on your device. If you know how to use a command line, you're perfectly good for installing PostmarketOS. And we also hope that it's possible for some even less technical people to install it based on the documentation. But then, if it doesn't work with your experience, please tell us why it didn't work for you. Or if you figure out that the documentation is a bit wrong in some places, please tell us. Please fix the documentation. The wiki is editable by everybody. We would also really appreciate some translations being updated, especially if you speak a non-English language. Both for example, in the Phosh UI, all of the apps that you use. Put your phone in the language that you speak, and then check which apps are missing translations, or whether the translations are not complete, or everything there. Also spread the word. There's a lot of different conferences going on. Let's say the PostmarketOS, the core PostmarketOS team basically doesn't. I mean, we don't have the time to be at all of the conferences. More or less, Frostcon and FOSDEM are like the two biggest conferences that a bigger portion of the team attends, but there's also plenty of others around the world. Both tech conferences and non-tech conferences, and like sustainability and like everything, could really use to get the word to more people. We will also we are doing more or less monthly blog posts about the things that have been happening in PostmarketOS. There's a lot of work. Some people are spending like days on these blog posts to make them work nicely. So they would really appreciate some help. Our podcast could basically use somebody to get it a bit more rolling again. At some point we were doing monthly episodes, but now we basically because of a lack of time, we are doing less episodes because also editing podcasts just takes a long time. If you're happy in helping out there, we would really appreciate it, and we can have more episodes there. And also funding grants. There's a lot of different funding grants available for improving the open source ecosystem. But actually finding these grants, applying for them, managing them is really a lot of work. So this can be done without any technical experience. Essentially just writing, if you like writing texts, you're perfect. And we also have a bunch of different ways written on postmarketOS.org/contribute. And also, if you have any other ideas of like how somebody else can help improve PostmarketOS, please send us an email. The email address is up on the slides. And that was it. Thank you.
Thank you for your talk, and thanks for all the work on Postmarket. Are there any questions?
Thank you for the talk. I was looking on the wiki for the community devices. There is actually a pretty large amount of rows where both mobile data, SMS, and calls are green. Mm-hmm. So one question is, how does this all work, even though you're trying to avoid like binary blobs and stuff like that? And the overarching question is, can I actually run Signal on something like that and be really clean on OPSEC? Thank you.
So the calling and SMS and modems, basically all of the functionality in Linux user space is handled by Modem Manager. This is handling the interaction with the modem firmware, which is running on one of these like separate CPUs in the same SoC. But it is a separate essentially operating system that's running there. That is proprietary, but it is running separately. It is separated off on the SoC, and from what Qualcomm wants the world to believe, at least, it is completely separate, and there's a lot of security protections in between. So we are using open source software to talk this Qualcomm way of communicating, which is called QMI, to the modem and basically telling the modem, please send an SMS. For Signal, I am not quite sure. I was asked this yesterday at the stand. There's a client called Axolotl, which is supposedly a completely independent Signal client. I don't know if this is working like as of today. Essentially, I just know from like many years ago that Signal is a bit hostile to third-party apps, and Signal Desktop was also relying on having an Android phone essentially paired to the Signal Desktop client. So you would need to try it. If you try it, please document it. Update there's a wiki page for Axolotl. Where they're saying something. I don't know if it's up to date. I don't know if this is from 5 years ago or from yesterday. But yeah, please try it out.
I have Telegram working. I switched from Android. I kept a backup, but Telegram also works if you turn all your Android devices off.
Yes, Telegram Desktop is completely independent. It's a completely self-standing Telegram client. There's also, I don't know if it's packaged yet, but there's also from Ubuntu Touch, there's a mobile-friendly Telegram client called Teleport. But yeah, Telegram Desktop I think should just work on Postmarketers also. Yes.
Yes, it does work, and it is even usable.
Cool.
Any other questions? Oh.
If someone wants to contribute to PostmarketOS, but doesn't have any experience in working with mobile devices specifically, just a general basis in computer science, where would one start to learn about these devices, about working with Android phones, with ARM devices?
So the good thing is that since Postmarketers is just a regular Linux distribution, like it is generally it has the same stack as Desktop Linux. So if you're familiar with that, like at least all of the higher level parts, so like the UI and everything, it's exactly the same. So I mean, it's just GTK technology, it's just GTK apps. For the lower level parts, there is definitely some, let's say, lack of written documentation at least. I think there were plenty of talks like over the years that give some amount of insight into like different bits of the whole stack, but it also differs a lot between different SoC manufacturers, for example. So how Qualcomm does, especially like modem things, is quite different to how it would work on a MediaTek device. Even though I actually don't know if there's any support for MediaTek modems with open source software yet, or Unisoc, or like any other manufacturer there. I am basically only working on Qualcomm devices for more or less since I am mostly interested in Fairphone devices, also since before I was working at Fairphone. Like basically all of them are Qualcomm, so that's why my personal involvement is more on the Qualcomm side. But yeah, for actually, I mean, you can run Postmarketers in a VM and then have essentially the same UI and the same stack installed in QEMU and work on that then. And otherwise, yeah, install it on your device. For installing it, there should be a good or reasonably good documentation there. As I said, if it's not good, then please tell us. And with that, you can then SSH into the device and do you have a command line, and you can compile stuff there. You can install a compiler. You can install all of the build tools. You don't have to develop on your desktop. You can actually develop on the device itself. Or if you do app development, you can just develop on your desktop completely. You just resize the app to the correct size, and then it's basically the same as it was running on the phone. Of course, with touchscreen, maybe if your laptop is a touchscreen, then you can even do the touchscreen gestures and everything and make sure that this is working correctly. And otherwise, develop it first on your desktop and then just try it on the phone, like just compile the same thing on the phone, run it, and then see how it works there. For example, I have developed an eSIM manager app last year, which is based on GTK. I was 95% of the development was actually done on my laptop. It's just a GTK app, and then if I want to check if it would look nicely on the phone, I would just resize the window to be the phone size and then see if it works. And then at some point actually, and also for that I actually made a sort of dummy backend to be able to develop it on my laptop more easily and not have to rely on the phone, because it's just way more convenient that way.
Understand. Thank you.
Thank you.
Anyone else? Okay, then thanks a lot for your talk.
Thank you.